Hi all, in this video I will show how you can seamlessly deploy a manual Oracle Data Guard in OCI using RMAN Restore from service. To make it simple to understand, I've broken the entire configuration into these few topics: architecture and use cases, prerequisites, prepare the network and the DBs, deploy, and then DR readiness. This architecture shows a data guard configuration across regions. Standby databases across regions ensures disaster recovery, high resiliency in the event of a disaster. Data guard enables you to quickly restore your workload to the standby database in OCI. In this video, we will be emulating a disaster recovery scenario in OCI Base database environment using RMAN Restore from service. Now, this video focuses on some primary use cases such as when you require multiple data guard environments in OCI Base database, multiple database for Azure Base database, disaster recovery with data guard, and for hybrid data guard scenarios, example Exadata to base database, though the hybrid use case might require some additional changes. Now, before configuring the data guard, here are some prerequisites. Gather the information that you'll need to set up the standby database and then provision the two databases using OCI console. Both databases, primary as well as the intended standby, will initially be in a primary role. This is the most important step to set up the network connectivity between the DB systems. You need to create a RPC for both DRGs and establish a connection between the RPCs. Allow traffic from both sides by adding an ingress rule for 1521 port to the security list for both VCNs. And then finally test connectivity between the DB systems. To prepare the primary database, here are the steps that you'll need to consider. Ensure that the database is in archive mode, flashback and force logging is enabled. Most importantly, the database should be open and in primary role. The automatic standby file management should be set to auto, and then set the broker parameters. Note the current listener status, TNS entries, SQL net.aura details, and primary database configuration. Configure the static listeners and update TNS themes.aura. Lastly, copy the password file and the wallet files to the standby DB system. Now, to prepare the standby database, as shown in the slide at the right side, note the current DB name and the unique name. The standby DB name has to be the same as the primary DB name. Note down the wallet location and the DB configuration details. Then shut down the database and delete the database files. Copy the primary database password and wallet files to the standby database location. Configure static listener and TNS. There are several methods you can use to create a standby database, but the recommended approach is to create a standby database using the RMAN Restore from service. Now, this method can be used to instantiate a standby database in lieu of RMAN duplicate database command. And this method is very simple also to use. So here, start the database in no mount mode. Restore the standby control file from the primary service, mount the database, set Oracle directory permissions, and then finally restore the database from the primary service. After the restore completes successfully, validate the standby database. The database mode should be mounted and the database role should be standby. As seen over here, it's mounted and the database role is physical standby. At this stage, the data guard configuration is not yet initiated, and hence the MRP and RFS processes are not started. The next, you have to add standby log files to the primary as well as to the standby databases. As per ME best practices, standby redo logs are recommended to be identical in size as online redo logs and to have at least one more standby log file. Configure the data guard broker parameters on the standby database as shown in this slide. The DG broker parameter should be true. Then use the DG manager and create the primary and standby configuration. The broker configures the DG config parameter and the remote archive destination with the default values for asynchronous transport. So once you enable the configuration, the broker automatically sets up the redo transport services and log apply services. And this is where it makes it more simple, because in case of the RMAN duplicate, you will have to configure these values and these parameters manually. On the primary database, then do some log switches and then check that the MRP process is applying the redo as shown over here. So in this slide, the current log sequence is 419. Here you can see the RFS and MRP process is started, and that the redo from the current log sequence, okay, is 419 and is being applied to the standby database. Finally, validate the DR readiness by doing a switch from the primary to the standby database and vice versa. As seen here, use the validate database command and ensure ready for switchover is showing yes. Then switch over to the standby database. Once the switchover is successful, validate the databases. As seen here, the standby database is now the primary database, and the original primary database is now the physical standby database. In the next session, part 2, we shall see how to prepare the primary and standby database, how to deploy the replication, and lastly, we shall validate the DR readiness by doing a switchover. Thank you for watching.